So after developing this equation with the help of the first two first order conditions, we use the third first order condition, which is this one, and we can substitute the value of x in it. As you can see, it is put in a box to highlight, and in the next step you can see we have substituted this value that we have developed in the last video of x in terms of y. Now we can solve it by using simple algebra. As you can see, we have gathered the terms of y, and we have kept px, py separate, as well as the coefficient. Simplifying the coefficient, which is highlighted with overline, and this term will remain the same, whereas this will become y. So we are in search of the value of y, which is the Hicksian demand function for y. So we keep y here and we shift both of these terms to the other side. They appear in the denominator, and the next step we write them in a mirror image way. Finally, we reciprocalize this term, and in the numerator it becomes like this. We write it separately, u separately, and 1 over 0.9 separately. So in this way we have written the Hicksian demand function in a proper way, where the coefficient, the price ratios, and the utility, they appear separately. This was the Hicksian demand function for y. To find out the Hicksian demand function for x, we can use this equation that we developed by solving simultaneously the first and the second first order conditions. Here, instead of y, we can put y asterisk h, which is the Hicksian demand function for y, and this will become not just x, rather Hicksian demand function for x. So here in this box we have substituted the value of y asterisk h, and then the process of simplification will take place, separating this part on py and px, and then we merge the py values in the numerator and px values in the denominator. Now we can solve this easily. The numerator, the result would be this, and in the denominator the result will be this, and then we can write it together, and it will look like this, the Hicksian demand function for x. Now we have both the Hicksian demand function for y and Hicksian demand function for x. Now we can substitute them in the budget line or the expenditure function, and this will give us the minimized expenditure function E asterisk. So these two values are to be substituted. Here you can see px remains the same. This is the value of xh asterisk, and py remains the same, and this is the value of y asterisk h. So this is the formula. I just add it because this is going to help us to understand that this is xh and this is yh. Now the process of simplification will take place. These are the two x terms that we have gathered from this expression, and these are the two y terms. Both of them are put under an overline, and this overline can be further solved. Here you can see we have solved it, and the answer is px raised to the power 0.45 and py raised to the power 0.5, because this was with the 1 and this px was also with the 1. Now we have py as it is from the last step, and we have also taken u as a common factor. As you can see, this box around u and this u, we have taken it as a common factor because it was common in both of these terms before and after this plus sign. Now with this we can write it in a more elaborated way, readable way, and when we look at this couple of terms, they are also the same. When they are the same, we can take them as well as common factors. So all these three terms now are common factors, We are left with these two numerical terms. Solving them, we get 2, and finally we get the minimized expenditure function, which is based upon or in terms of px, py and u. Now finally we can apply Shepherd lemma on it, which we will do in the next video. So this was the second part of the video in which we did the Hicksian demand analysis, and we also developed the minimized expenditure function. Thank you.